This illustration deals with busway taps in accordance with 240.21e. I don't get this question often anymore, but used to. I would get this question quite a bit when these busways were really becoming very popular in industrial type related facilities. And the designer and sometimes the installer thought, well, that engineer's made a mistake. I can't tap a bus. And we would have to go over this with them, but we'd always tell them it's not the size of the bus now. Just like in the 240.21b taps, it's the size of the overcurrent device. So if you had an 800 amp bus with an 800 amp overcurrent device, or a bus that was 1,000 amps, say, with an 800 amp overcurrent device ahead of it, and they upsized the bus for voltage drop, correction factors, or adjustment factors, and we're just throwing that out there. Then step one would be the application of 240.21e, but notice we have a 800 amp busway with a 800 amp overcurrent device, and we're reducing down 300 amp. And notice by following the application of 240.21e, we could make that tap in reduced size of 300 amps 50 foot long. And we would not need a protective device where we make that tap. And this is where many times our electricians would want to set an overcurrent device there, install it. Which I know you don't have to do that. Whoever designed this, whichever engineering firm, contractor, whoever had the responsibility, they were correct. Now step one is the 1/3 rule. So 1/3 of 800 is 266.7. So rounding that up to 300 amp busway is large enough to supply the 266.7 amps. So the 300 amp busway tap is equal to or greater than the 1/3 rule, which produced 266.7 amps. Therefore, the tap complies with the NEC and can be routed 50 foot when you review 368.17a, right in that area with this exception 1 that permits this tap to be made without installing a protective device at the point of the tap. So figure 9-30 just simply illustrates busway taps when they are made in accordance with 240.21e as well as 368.17a exception 1.